Okay, hi everybody, I'm Scott, and in this video I'm going to take a look at the ICDoc ToughArmor M2 NVMe SSD mobile rack for PCIe expansion slots. Basically, this one is the 2-drive version. It has two well, I shouldn't say hot swappable. I guess that depends on the PCIe implementation on your computer. But anyway, they're removable through the back in sleds. Well, let's take a look at the actual product. And this video is also going to be an epilogue of sorts for my backup server project. I'm assuming these are thermal pads. Yeah, thermal pads. One screw. Instruction manual. And the card itself. Now, I said in the backup server video, oh, this is a little bent, that I would only do an update if there was a problem, and there has not been a problem. The servers work great. It's just there were a couple of things I realized I forgot to mention in that video. For example, the noise of the fans and the drives and the power consumption. And I should show it in its ultimate resting place, so that'll be at the end of this video. And this does relate to that video in that I originally bought this card to use in that server, only at the last minute I decided not to. I was going to store, and I have SSDs to go with this, I was going to use these SSDs in this thing to store my most valuable files on the backup server. The idea being that if the main RAID array failed, I would have these in RAID 1, and they would still maintain the most valuable data. Ultimately, I decided not to because my most valuable data is also backed up off-site and will be backed up to tape, so the failure of that RAID array is not really a major concern. But I did mention the card in that video, and I thought I would solve the question of whether the older T640 system, and it's not that old, that system was manufactured in 2021, and the BIOS did have an option for PCIe bifurcation. I should back up. So this card supports an 8-lane PCIe slot, or an X8 as you might see it labeled, although it has this blank part, I guess for physical support, so you can put it in a 16-lane slot, and then just like a video card, it's got this little capture notch for that, you know, that thing that video cards have, that video card slots have, that it's super annoying to get at sometimes. Yeah, the one that I hate personally, so I can lock into that. Although, I guess you do want this locked in pretty well because it has these holes in the back for inserting and removing these caddies. And I guess, you know, you wouldn't want this being all wobbly in the chassis in the PCIe slot as you're pulling these out and pushing them in. Whatever. But I digress. The point is, this is an 8-lane PCIe connector right here, and PCIe bifurcation allows the system to allocate different lanes for different purposes. In other words, it basically splits, let's say, an 8-lane slot into two 4-lane slots. And 4 lanes is what a NVMe uses. So essentially, this is, I don't want to call it a PCIe splitter because that's not really what it is. A splitter is more like taking a channel and then splitting into two. This is more like taking 8 channels and splitting them into 4 and 4 separate channels, and they're completely independent when they send and receive data to the PCIe bus, which in theory should mean you would be able to get full utilization of the speed of these disks, because in any system, I mean, 4 lanes of PCIe, it could max, if it could theoretically max those out, it could theoretically still max them out in here, even those 2 drives, they each have their own dedicated 4 lanes. Don't know that I explained that in the best way, but anyway, this is just taking an 8-lane PCIe slot and making 2 4-lane slots out of it, theoretically having no detriment to performance. The only downside about this type of card is that your system needs to support PCIe bifurcation, which, as I said, I think the T640 does, but let's prove it. And I also just want to test this out in general. One of my next big projects is going to be completely replacing my file server, which is, it's all mirror reversed, which is there. And also a disk array that's connected to it right there. And right now, it's a behemoth with like 48 disks attached to it, mostly in this chassis. This chassis is a 36 disk chassis, 24 in the front, 12 around back. and then that's a 12-disc array up there. I want to simplify that. The main chassis is full of 3 terabyte discs because I built it in 2016, and 3 terabyte discs were the cheapest on a per terabyte basis. Anyway, the point is it was cost effective in 2016. Nowadays, it's a little long in the tooth. And on top of that, I bought the chassis used. It was probably already quite a few years old in 2016, so I don't know how much life it has left in it. Specifically the motherboard and power supplies, although I could swap them out, obviously replace them, but with probably old power supplies and motherboard to fit in that chassis. So an upgrade is in order. And so I do plan on using this, and maybe even 2 of these, in a T740 XD, and I'll use these for high-speed, high-demand storage, so that I at least have some SSD storage in that, because I want to use all the drive bays for hard drives. Even though the did I say T740 before? I meant R740 XD. Wow. The R740 XD chassis that I have has 4 2.5-inch drive. The R740 XD I have back there, well, one of the 2, you can see them down there somewhere, has 4 2.5-inch drive bays in the back, 2 of which will be used for the OS, 2 of which I guess I could also use just for storage, but it's not going to be as fast as a good quality NVMe SSD if it's going through the SATA bus. And I was going to say RAID card, but I'll be using it in HBA mode. So I didn't buy these for no reason. They will get used. Anyway, enough of my rambling on. Let's take a look at the card itself. Now, first of all, something I noticed just quality-wise, this bracket was bent a little before, and that's because it's like incredibly flimsy metal. Like, see what I mean? I'm not even applying that much pressure to that to get it to bend. And high-quality cards tend to have like heftier steel brackets. In fact, this is one of the flimsiest brackets I've seen since like the 90s. I don't know. It's giving me like retro vibes. The part in the front here is basically just a mechanical assembly to hold the hot swap drives, which I think go this way. Yep. And in the back, it looks like this if it's populated, and it's kind of like any hot swap NVMe or SSD or hard drive where it just has this latch, pulls out. Great. Electronically, it's very simple. It's got this one main chip on it, presumably to communicate with the host PCIe controller. I will take a picture of it and post a close-up of the markings now. And also, I will, in editing, check out what this chip is. It's probably used, if I had to guess, from the traces on the PCB to drive these 2 connectors, which are presumably, and we'll check the manual for once, activity LEDs, or connectable to activity LEDs, because there's a little transistor next to each of them. No, and another one of these 8-pin chips up here. This is the manual. It's not very comprehensive, but then again, I guess there's not too much to know about this. I'll take a quick look and let you know any highlights. I guess the single drive version of this is half height, and therefore you could use a half height bracket with it. Obviously, this is a full height card, so not possible. It comes with 4 thermal pads of varying thicknesses, 1mm and 0.7mm. And that's to bond the SSDs to these sleds. But that it's really just more of a heat spreader than anything. I mean, obviously it'll sink the heat outwards, but if you look at the way this is inserted in here, this is pretty well surrounded on the back by the PCB and the plastic chassis, and then on the front it's a little bit obscured, so it's not going to get a great deal of airflow over it. But that's excusable because, I mean, I don't know how you'd implement a proper heatsink with fins in a sled like this. It's probably possible, but they didn't do it. Oh, and that's nifty. I didn't even notice there's apparently an LED indicator on the back of this. Wait. Oh, yeah, there is. There's a little light pipe right there. And that goes, yeah, that goes all the way down the side here. Oh, there you go. Well, that gives the best indication of where the light pipe is. It's right there. It's a bit out of focus, but there you go. That's where the light would shine out. I think I was being over pedantic where it said LED indicator, because there's no LED there, but there's apparently an LED on the card that shines into that light pipe. And yeah, there's the LED and the other one. Weirdly, they're not surface mount. I think it was just to simplify manufacturing. They use a through-hole component. You can see those two silver leads there and there. They just use a through-hole component so they could send it up from the board and bend it over and put it into a plastic like holder for the LED to get it to point that way. Because if it was surface mount, it would just be on the board. They would probably have to have some kind of like light pipe to send the light forward or up and then forward out the front of the card. So yeah, I guess that's why they did that. Okay. I actually didn't realize when I bought it that it had LED indicators there, and I quite like that. Because I'm not going to connect anything to these. We didn't even establish that's what that's for. Yeah, okay. That is indeed 2-pin LED signal output for drive activity. PCIe 4.0 times 8 golden finger. I mean, presumably because they're gold-plated contacts. But is that a term that I'm not aware of? Golden finger? Outside of, like, James Bond? And yeah, here it points out, make sure your motherboard supports PCIe Bifurcation, enter the BIOS menu, and then fully connect the device's PCIe golden finger into the system's PCIe slot. This shit is a golden finger. Yeah, it's just referring to the PCIe connector. The golden finger. I'm going to call it that from now on. Okay, and then the rest is, this is all just basically about the thermal pads. If the 1mm pads are too thick, use the thinner ones. Doy. Alright, well, anyway, let's open one of these up. Press the edge to... Oh, yeah, that's really... I feel like it didn't need directions. It could just say press here, and then it looks like it latches on in the back first, and then pokes down in the front. Yep. Alright, easy enough. So the thermal pads are basically the bulk of the installation here. Oh, I should also talk about... These are both 4 terabyte drives, as you can see. But they're different brands, as you can also see. The reason for this, they're comparably performant. They get similar, incredibly high reviews, both the WD Black I've used the SN850X in another video, and I also use Samsung Pro drives in a lot of other places. So I don't really have a brand preference for high-end SSDs other than like one of these two, at the consumer level, obviously. They're not like enterprise drives, but they don't have particularly high endurance. It probably doesn't say, because they never say. You kind of have to look into the specs. Because I feel like endurance for me is one of the most important aspects of an SSD, except in this application where I'm probably not going to use these drives for anything like data mission critical or like failure mission critical. Like if these failed at some point in the middle of a day, it's not going to take down a corporate server. You know what I mean? It's going to take down one volume on my file server, and that's if both of them go wrong at the same time, because they'll be in RAID 1. And that's the reason they're different brands, is just because I bought them from the same seller, I think Amazon, and this way I just know that they came from different lots, right? Because if I just bought 2 of these or 2 of these, they could have been manufactured in the same run, in the same batch, and if there was any kind of manufacturing defect, it could be present in both of them. That's why, if you're doing RAID 1, I would always advise you, if possible, use the same brand of drives from 2 different batches, 2 different production runs, whatever, or use just 2 different brands with comparable specs. And if you're going to go with the same brand, that's fine. What I usually do in that case is I'd buy 1 drive from Newegg and 1 drive from Amazon, for example, or from whatever 2 sellers you prefer. The point is, just try to get them as far away from each other in production as possible. Obviously, there's 2 different brands. These are made in 2 different factories, and this is going to use SanDisk chips. This is going to use Samsung chips. So they're obviously not going to have any kind of, I shouldn't say obviously, maybe there is some common component, but they're not going to have some common component failure. And I know that this is a 5-year warranty. Samsung also has a 5-year. I mean, I've never had an SSD die, I think, within like a 5-year warranty period. And this drive is, let's see, it looks like 4 flash chips. I can see 2 under the label, 2 on this side, obviously, and then I'm assuming that's the controller chip. Yeah, Samsung's packaging, I guess, looks a little nicer, but... Ooh, this is using higher density flash chips, because this doesn't have anything on the back, anything chip-wise. It's just a sticker. And on this side, there's only 2 flash chips in the controller. So these must be 2 tera. Yeah, you could fit 8 terabytes on here easily. Okay, so let me just cite the drive. It has a little notch right there, so that you can't put the drive in the wrong way around. So if we line that notch up there, presumably that's where the drive sits, with just the golden finger sticking out. Although we got to make sure those thermal pads hold it nice and tight, because there's nothing to hold it back on the insert force. The Western Digital drive is basically like 50% thicker than the SanDisk drive. I mean, than the Samsung drive. Jesus, gotta stop doing that. So I'm gonna guess we should probably use the 2 1mm pads for the Samsung. And they do say in the manual, if there's a significant height difference, you can use you can cut up the unused thermal pad to pad it out. And I don't know about the quality of these pads, but hey. So obviously these have protective film on them, but just to get an idea of the thickness we're dealing with, I'm going to just see how this goes together with the Samsung drive first. Goes face down, so in this case, the flash chips are all on this big aluminum or magnesium, I don't know, surface. Now that's too thick. Okay, it's got to be the 0.7, because it doesn't want to slide all the way out, because what's interfering with it are these metal brackets down here at the bottom. It kind of comes out and down, and the card has to go under the lip of that bracket. I'll zoom in. Let me get a good... Yeah, I'll zoom in digitally so you can see where that is. And if I put in the 1mm heatsink pad, it hits that metal right there. Now that being said, the drive should be smushed pretty good against the thermal pads for obviously good thermal transfer. And the thermal pad will compress over time and as you insert it. But still, I don't want to crush the drive either. I don't know. Let's just see. Yeah. And then that one slides in much farther. Yeah, all the way up to that little notch in there. And you can see it sticking out. But I will probably have to use the 1mm pad, maybe then some, for the top of this, because it has no chips on the other side. And this drive may have a disadvantage being only 2 flash chips as opposed to 4, because, I mean, depending on the architecture of how this writes, if it writes across one chip and then the next chip and then the next chip and so forth, it wouldn't matter. But if it writes, let's say, I mean, I'm sure it does it in larger chunks, but let's say it wrote 4 bits to this and 4 bits to this to make a byte. And in this one, it wrote 2 bits to this chip, 2 bits to that, 2 to that, 2 to that to make a byte, just as an example. Then this one would heat more, this one would heat more evenly than this one. And you'd have the heat distributed across a larger surface area. I don't know. It's actually something I don't know that I should look up. Now they do say in the manual you can use the excess from one of these pads to make up that thickness, as I said before. There's 4 pads though, and you need all 4 to install the SSDs. So I think it doesn't specifically say that you should do this, but I think I'm going to just cut the thermal pad to the length of the drive rather than leaving it hanging out in the back, which I don't think would matter from any practical standpoint. cut it slightly longer than necessary, just to make sure we cover the entire thing. But really, you only have to cover the chips. And I debated in another video about whether I should take these labels off to just get better thermal contact. And my concern is, while I'm ripping the label off, it might take one of these chips with it if it's a little hard to remove. And so I opted not to remove it. I'm assuming this label is made of foil. It looks like it's made of metallic foil and should give thermal transfer. It shouldn't act as an insulator anyway. I wouldn't think Samsung would design it that way. Yeah, of course, that was one of the 1mm pads I just cut, but I'm going to need a 1mm pad at that length anyway for the other side of the drive. It's best not to touch it. I mean, just because in theory you get oils or dirt from your fingers on there that could act as an insulator. So that's why I left the protective film on the other side of this, just that I can get it in position and then smooth it down. It's not really adhesive, but like it's gummy, so it will stick to that. It's not going to just come right off. And it will hold the SSD in place pretty well because of that. But you can see it's like it's coming up as I'm trying to remove the protective film. That was my idiocy, by the way. It does give these little tabs to help remove the film. I cut them off. So don't do that. Don't be like me. Man, that protective film was stuck to that shockingly well. Anyway, SSD goes in, and yeah, it's positioned lined up all the way where that pin's hitting that notch, and it's sticking out the back. So that should be good positioning. And let me just throw a 1mm piece on there with the protective film, just to get an idea of how close we are. Yeah, I mean, you can see the thermal pad with the protective film can easily slide around in there, which means without the protective film, it's going to be even thinner. So we're definitely need to bulk that up. They don't give you too much in the way of spare, though. And they recommend cutting it up and putting chunks of it where they'll make the best contact. I'm just going to cut this one in half, I think. And then what I'm going to do is sacrifice a little bit more of the 0.7mm that I'm going to use with the Western Digital. This time I'll leave the blue tabs on the longer piece. And of course the controller chip can still get hot, so that should be good. Got a little dirt on there. Not going to worry about it because it's not even on a portion that's going to have any thermal transfer. I do a lot of projects on this table and it gets schmutzy. Kind of is what it is. Yeah, now that required some force to go down, and it's kind of like ever so slightly bowed up right there where the drive is. And yeah, I could feel like it had more of a, not hollow feeling, but it kind of, you could compress it more right there. And now it's pretty stiff. And it was completely unnecessary to make this thermal pad this long because it's not even making contact with anything. So you could have saved some by cutting that one a little shorter. Maybe I'll probably won't do that in the next one. It doesn't matter. Let's see how it fits in here and makes contact. Just brighten the image up a little. It looks like it's seated pretty well in that connector back there. And it's not quite flush with the back, but it doesn't really stick out. And in fact, the metal of the case will probably stick out about as far as that drive does. So it'll be very flush in the back, which is neither here nor there, really. Just thought I'd point that out. The backs of these sleds look like they're vented, and I guess technically they are. Like, some air could, I mean, the airflow in the case would be this way probably, but yeah, air's not really going to pass around there because you can see it's flat, the metal's flat to the other metal there as well as there. So you might get a tiny bit of air going through this hole and then around here through the, you know, I mean, like, you're not really getting airflow around this, is what I'm saying. And if you're, I guess, putting multiple of these in a chassis, you can see the thickness of it. You wouldn't get much airflow around them if you had a bunch of these cards next to each other, so you could really stack a system with NVMe SSDs in the back. Yeah, you're really not talking much airflow at all. And that's perhaps one of my main concerns about this for high performance, high writes circumstances, because writing to flash chips, A, uses more power, and B, that power is dissipated as heat. So if you're just reading from these a lot, if that's your use case, then if it's low writes, high reads, you probably wouldn't have too much of a thermal issue, but I'm going to guess these will thermal throttle but when doing a lot of writes, particularly if there's a card right up against the side of it here. And like I said, you're not getting much interface between this surface and the air in the case because of all the obstructions here. Anyway, I'll time-lapse putting the other SSD in here. Okay, well, not the greatest deal of finesse there, I'll admit, but yeah, I can feel it. It's pretty solid right where those chips are. It's definitely got good contact. It's being pressed down. You can see again, it's just a little bowed up where that is. Now, the only other thing is I kind of wish like this got more compression along its length so that it really like firmly seated those thermal pads onto those chips. Like some kind of, like if this cage was made of metal and it had some kind of like loaded, not spring loaded, but like a little bit of a bowed piece of metal right in the middle there to just push the middle of this down, I think that would be better. But I mean, who am I to say? They're presumably the experts. It is a little hard to insert when it hits that middle part, so it might be, you can see it like kind of sticks and then comes loose, which might be a good thing. You can see it's kind of rubbing against the top. You see it's like schmutzy now. So yeah, maybe I was overly critical. Maybe it is providing a little extra pressure on that. Yeah. Let's see if it'll work. And here's the big chonker itself from the last video, or the video before last, whenever it came out. This is the backup server, if you didn't see that video. T640 with 18 drive bays up front. Oh, it's not exactly light. And the 2.5 inch to 5 1/4 inch drive bay conversion thingy. These are the super cheap plasticky caddies with their plastic handles. I'm going to take out both OS drives. These are just used for the OS. The 18 drives that I just took out are obviously for storage. This thing is too heavy for me to pick up with all 18 drives and the weight of the chassis itself. I mean, I probably could deadlift it, I guess, but why? And I definitely am not going to be able to carry it upstairs, which is where it's going next. Let's get this thing opened up. And back here is the NIC that I'm not going to be using. Although that brings up sort of one other point, is that you got to be careful when populating PCIe slots. If you were to put this card right next to this card, the heatsink on this card would be at least partially obscured, but that's common in PCIe slots. You always have cards next to each other. Well, the problem is if this thing is generating a lot of heat and that's not being vented out of the case in any meaningful way, because, you know, this has a slotted bracket on it, right? So you get some airflow across the card and out the back of the case. With this next to it, you'd still get a little bit of that airflow, but it would be a bit obscured, and with this thing generating all that heat, the only place for that heat to go off the back side of this would be past this card and through those air holes, and so you'd have a lot of local heating, and that could cause this card to overheat and either throttle down or die. You just got to be careful what you're putting where, especially if you have options like in a vast open chassis like this. For example, I'm thinking it's probably better to put this card up here rather than down here. The main reason for that being this fan cage. I should show you the way it lines up. So first of all, there's two additional fans back here which pull air through this shroud, which pulls air over the RAM and CPUs. This cage obviously has 4 fans in it. The way it's situated, basically 2 of those fans just blow air into the air shroud. The other 2 on the outside are partially obscured by the air shroud, but I would say like 2/3 of them are exposed to the rest of the case, and those are what provide airflow through the PCIe bays on either side of the air shroud. Up here, all I have are 2 SSDs that are mostly going to be used for reading, and actually not doing much at all because they're OS disks, so just writing the occasional smidgen of log file and just being read from when they boot up or need to run a script or something. Very low data transfer volume. These are not going to get hot at all. Whereas this array of 18 drives will get quite warm, I dare say hot, and this fan cage will be pulling air past those drives and into the rest of the chassis. So I would presume that this lower PCIe bay is going to generally run warmer than this upper one, because this upper fan really only covers the 5¼ inch drive bay and a touch of the hard disk array, whereas the lower fan is pulling air almost entirely over the lower 6 disks in this array. Like, this fan lines up almost with the entirety of this lower set of drive bays. I'm not actually going to be putting this card in this chassis long term. We're just doing it for testing purposes today. But things like that, just take into consideration where your heat's being generated in any system and where it's going to go. This card in the manual said it's rated for up to PCIe 4. That's Gen 4. This is a PCIe Gen 3 system. It's printed on the motherboard. You can always look in the manual if you're not sure. So this is capable of higher performance than this system would allow in theoretical maximum. Oh, and for round numbers, PCIe 3.0 or Gen 3 PCIe, whatever you want to call it, has an approximate bandwidth of 1 gigabyte per second per lane. And that's gigabytes, not gigabits. And per lane is important because an 8-lane card would have a theoretical maximum of 8 gigabytes per second transfer across all lanes used at once. And since these NVMe's have essentially 4-lane PCIe slots assigned to each of them out of this 8-lane slot down here, that would be 4 gigabytes per second maximum throughput from either or both of these NVMe drives. PCIe Gen 4, I think, has a maximum of 2 gigabytes per second per lane, and Gen 5, 4 gigabytes per second per lane, I believe. And if we just want to look at the raw specs on these just for fun, because obviously the specs printed on the front of packaging and published by manufacturers not always going to reflect real-world scenarios, but it says read speeds up to 7,450 megabytes per second, so that would be 7.4 gigabytes per second roughly. This one says 7,300 megabytes per second, so let's call them both about 7 gigabytes per second. We only have 4 gigabytes per second max that this system will be capable of doing. This being a Gen 4 card, in theory, it could do 8 gigabytes per second per drive, which would theoretically allow these manufacturer specs to be true. So unfortunately, in this little experiment, we are not going to be able to max out these drives. Yes, I know we all just heard me say that I was going to put the card in the top set of slots. This is the bottom of the case. It's just for camera logistics. I can't really get a camera over that without sliding everything around. It's fine. And I did just want to show you in close-up, this chassis has 9 PCIe slots. That's 8-lane. That you can see the markings: 4-lane, 16, 8, and another 16. So this card could go in any of these slots other than the 4-lane slot. I know it's physically an 8-lane slot, but it says PCIe G3 X4 CPU 2 there, and so that's only 4 wired lanes, even though it's an 8-lane connector. Huh. It was the bracket was sticking. There's another problem with this card though. Next to the gold member here, it's got this little extra tab for just for stability. If you're putting this in a 16-lane slot, I would assume, because it has this extra notch. And in theory, that notch should ride on the outside of an 8-lane connector, so that you could put this in an 8-lane slot. I don't see why they wouldn't want you to. But the bracket was snagging on this end, and on this end, this piece of plastic right here at the end of the connector is just a little bit thicker than the notch provided on the card. So it won't seat in that slot. Now your mileage may vary. Different PCIe connectors would have different margins there. But yeah, without modifying the card a little bit, just by dremeling that out or something, it's not going to fit in that slot. Which is unfortunate, because you might only have an 8-lane slot in which to physically locate this card. Yeah, it fits fine in the 16-lane slot. Okay. Well, it's there. Not too happy about that. Let's get the cover back on, boot it up, and test the drives out. Well, I mean, I'm kind of putting the computer in shot, but I don't know why. There's nothing to see. I will point a camera at the back of it so we can see activity LEDs in the back. And I'm just going to be booting into the live version of Ubuntu Desktop from this USB stick. It's not out of any kind of wild personal preference for Ubuntu, but it's what I have handy and what I used in the last video, and it worked fine with this system. I took a second to cable it up, and you'll notice I made one change here. I moved the card from these lower PCIe slots up to this one. And the reason for that isn't anything technical. It is just so that it more easily appears on camera without me having to adjust this tripod. That is really the entire reason. There's no technical reason at all for it. And the way the card is oriented here, most of the heat dissipation is going to be on the surface on the top, so that should get decent airflow over it. So yeah, up here we can see the LEDs. If I put it down below, the LEDs would be less visible. So there we go. And on the other end of things, we have a cheap Dell keyboard, although not as cheap and crappy as the current generation of cheap and crappy ones they send out. At least this has full-height keys and not chiclets. A SteelSeries mouse, which is better than necessary. And most importantly, this box, I just wanted to point out, it's VGA to HDMI. It's a decent scaler and gives decent video quality going from that format to that format. And that's how I'll be showing you guys the output from the computer. Speaking of which, let me get it booted up. And I will time-lapse through all this boot crap really quick. Slot bifurcation. That's what we want. Should I try auto discovery? Yeah, let's try auto discovery first to see if this card works with that, right? If I wasn't making a video about this, I would just manually enable bifurcation in that slot just to avoid any potential issues rather than going through the whole boot process again. But you know what? Let's see. For the sake of the video, let's see if that works. And I guess while that's booting up, I just noticed that the two LEDs are on and just showing green on those cards. And according to the manual, solid green means power, flashing green means access. There we go. NVMe 0 and NVMe 1 are appearing. Okay, so auto detect bifurcation does appear to work, because those are the only two possible NVMEs in this system. And obviously the default platform settings, whatever is said in the BIOS, does not include bifurcation. What I need to do is create bootable media that's actually persistent, so I don't have to keep installing the same shit every time. Okay, SanDisk 990 Pro is NVMe 0, and therefore the Western Digital Black is NVMe 1. I feel like that font is not legible at all. Like I said before, theoretical maximum on this bus should be 2 gigabytes per second, and these drives, I don't think... Actually, what are the specs for write on these drives? Because the amazing spec of whatever it was, over 7 gigabytes per second printed on the front of the package, I gotta imagine that's read performance. And see, I should just point out, the endurance figures, let me zoom in, are not that great. On the 4 terabyte drive, it's 2.4 petabytes written is not bad. It's not as good as like an enterprise drive, but that's actually not as bad as I thought it would be. So that's pretty good, but the smaller the drive, the less endurance it has. So yeah, another reason I opt for 4 terabyte drives. So yeah, the figure printed on the front of the package is the sequential read performance. Sequential write, though, should still be pretty good, although I did only use a 1 megabyte block size. Because of course what we're doing here are sequential writes. Let's just up the block size to, oh, I don't know, 64 meg and see how much that improves it, if any. Because I suppose even though it's not scientific, the LED isn't consistently blinking. Now it kind of is. Yeah, I'm assuming it's buffering some of those writes, and it's actually probably able to do more than that. Oh, that got slower. Well, damn. And by the way, never run this command on a drive that has any of your data on it. I want to see what this does to the CPU. Yeah, that's just saturating the CPU. I mean, with DD, the CPU could be the bottleneck, but not with the larger block sizes, I wouldn't think, although I should have checked that, to be honest. Oh, we still got 1.1 gigabytes per second, so yeah, DD might just... DD is not necessarily the best thing to test it with, or Dev Zero. I just figured I'd throw it out there. I'm just kind of curious to see if this also saturates the CPU. Yeah, let's have an update. Yeah. Okay, so it's actually CPU bound anyway. Four gigabytes per second is the theoretical maximum. So the average read rate is nearly hitting that. Yeah, it still uses a sample size of 100 megs. Why did the Western Digital get an average write rate of 3.3 gigabytes per second, and the Samsung... Okay, well that was pretty consistent. Why was the Samsung so poor then? And I know that this probably isn't your favorite benchmarking utility in the world, but I'm not actually trying to benchmark the drives so much as just make sure they get good throughput on the PCIe bus, which I don't understand why the Samsung's write rate... I mean, I don't know this test methodology either, but apparently it's good enough to get a result of 3.3 gigabytes per second on the Western Dig, but not on the Samsung. But there's no way its write performance on linear writes is going to be that poor. With read and write speeds up to blah blah blah. Yeah. Sequential write up to 6.9 gigabytes per second. And performance may vary, but yeah, we should definitely, obviously... I mean, look, I knew less than 500 megabytes per second was definitely wrong. I just didn't know how wrong it was. So here's what we can try, and this is probably a bad idea, but I kind of just want to test it out for my own sanity. I made a comment earlier about these being hot swappable. I accidentally made a comment about these being hot swappable, but how angry is my PCIe bus going to be now? I don't even know which one I just pulled out, but... Oh no, that froze the system. Yeah, I kind of figured. That's okay though, because the thing is I would have had to reboot anyway. My whole plan here is to swap the two drives and then see if that cures the performance issue with the Samsung. Now it's not showing either drive. It's the next day, well, the next night. I had a busy day today. I did put the backup server upstairs. I'll show that process and talk about that at the end of the video. This is the computer I'm going to be testing the card out. Where's the card? Oh, there it is. Yeah, so I'm going to be testing the card out on this computer just to see if it works in there at all, let alone properly. But before I do that, I have a small mea culpa, not just to you, the viewer, I guess, but to IcyDoc, because I missed an important feature, or I guess I should say aspect. It's not a feature necessarily, but I happened to glance at the manual looking for something else, and I realized this moves, right? And this tab is supposed to hold the NVMe drive down. And oh, and then it locks in because these pins on the side of the cover will latch into little notches in that sled. So it'll lock in place and hold the NVMe from like popping up in the back or getting pushed in, I guess, by the connector when you push the drive in. It's a mea culpa in that I should have pointed that out. I don't think that was the cause of my problem because the drive was always seated properly in that little location notch, right? And never got pushed in. I don't think this lock would have changed a damn thing about the experience, but I will use it. And because of that, by the way, I cut the thermal pads long on purpose just to make sure the entire circuit board and chips were covered. I should have cut it a little shorter so that the notch could fit over. At least cut the top layer shorter. And of course, this is the one I bulked up, so it's a bit of a mess. Yeah, the bottom thermal pad, leave as long as you want. But I guess before I put the top one on, let me just show you. This slides over there and just clips the end of the drive in. So now it shouldn't fall out. But ordinarily the drive is squeezed between the two thermal pads anyway, so it wouldn't fall out anyhow. It's definitely a good thing to have that latch. I'm glad it's there. It gives an extra sturdiness to the mounting. And of course the thermal pad get a little bit of grunge on it, but that's fine. This is the back of the card, and like I said before, I mean, I'm dubious. Oh yeah, these are the ones that are that way. I'm dubious about how useful it is to transfer heat onto this piece of metal because it's so obscured in the thing. But anyway, let's not re-adjudicate that. Let's move forward. And I'm still also curious. I mean, this Samsung drive could be faulty in just like a different way because, of course, it shouldn't have got write speeds rather of, what was it, 300 to 500 megabytes per second. It should have been a lot faster than that, like the Western Digital was. And it's not this model of Samsung. These are great drives. And one concern that clip here also doesn't really ameliorate is that I would prefer there be more pressure right here in the middle of the drive as well. I guess you could put a little extra thermal padding there, but then it might put too much pressure. I don't know. I just don't like how I wish this cover piece sort of slid in or something and was locked down all along a channel in here. Because like you can see, it's bowed ever so slightly up. And I feel like it should be providing even pressure along the whole drive to keep in good contact with thermal pads on both sides. But with that latch, I guess it's in good contact on this side, and that's the side that matters. I'm probably overthinking this, but there we go. And I guess, you know what, just for posterity's sake, let me use the latch with the Western Digital as well. Yeah, this drive's a little thicker, so it bows out slightly more than the other one. A little less of the golden finger showing, to be fair. So maybe it is seating better. Maybe I am an idiot. Who knows? Let's see if it works. I haven't booted this computer up in probably 2 years. I had bought it originally to use as a video capture device. You can see it's got an Elgato capture card in here. And the reason for the purchase of this exact motherboard, I don't remember the model number. I don't remember the exact specs of the system, but it's got a big-ass fan in the front. Decent quality PSU in the back. It only has, on this mini-ITX motherboard, a single PCIe slot. And so the CPU in here is an AMD CPU that has a halfway decent integrated graphics package on chip. I say halfway decent, it's not like it's going to compete with a discrete video card. At least not a good discrete video card, but good enough for full screen 4K video, which is really all I needed it for. And of course, that slot really, for most people, it would probably be used for a GPU with this motherboard, but for my purposes, we'll be using this, and fortunately the onboard video will still be usable. Yeah, the card is fully seated, but that bracket's not lining up great with that screw hole. Yeah, so I'm like, I mean, it's okay, it's fine, it'll work. It's just that I'm not like super happy about IC Doc's quality of materials. The drive trays, the sleds are great. Like, they're very solid feeling, good quality metal, you know, all of that feels nice. But then this bracket just is a letdown. And the plastic cage around here. All right, let's see. And if you were curious, it is a Ryzen 7 Pro 4750G with Radeon graphics. That's why I bought the CPU in the first place. Ooh, base speed 3.6, nice. 8 cores. Yeah, it's a pretty good CPU. Oh, I guess it did a fast boot. Let me do a proper reboot on this thing. That's approximately how long it's been since I've used it. So, like 3 years. Damn. Almost 3 years. I'm not sure what the BIOS keys are for this, so I'll do the usual dance while it's booting up. I have no idea what key it was for the BIOS because it gives the BIOS message so quick. Okay, it's detecting the Samsung, but not the Western Digital. That's probably because bifurcation's not enabled, or maybe not even possible on this motherboard. So it's detecting one of the drives. Interesting. Oh, okay, so this is a Gen 3 motherboard, by the way. PCIe 3.0 or 3.1, I guess. Alright, I am going to go to I/O ports. It's going to differ motherboard to motherboard, of course, BIOS to BIOS. But PCIe bifurcation, we got a choice of 2 8-lanes or one 8-lane and 2 4-lane. Now, ideally, I guess we need 2 4-lanes. I'm just hoping that it allocates the 2 4-lanes to the side of the connector that actually has pins on it. But let's see what happens with that. Alright, well, I'll boot it up. Let's just hop into computer management and see if we actually have the disks. It's showing one of the two. That probably means it's bifurcating the PCIe slot correctly, but it's putting the 8 lanes on the edge of the connector that this is connected to. Well, that sucks. Alright, I don't think this is going to be the system for this solution. This is a potential problem that anyone might run into with this card. Even if their system supports PCIe bifurcation, it might not support the right layout of bifurcation. So this card is in a 16-lane slot. So the slot is physically this wide, and on the motherboard it has electrical connections all the way across. So it will have connections here, even though the card clearly does not. I think what's happening in this case is that it's bifurcating the slot into one 8-lane slot, and it's using these pins for the 8-lane slot, and then 2 4-lane slots, which would be here and here. This card is really not compatible with this motherboard if you want to use 2 drives in it. It does seem to work in the 8-lane portion of the slot that's allocated, but it's only hitting one drive. So presumably one of these drives is going to be roughly probably on these pins. The other drive is going to be on these pins. And so it's able to access the first drive on the first set of pins probably, and it's ignoring the second one because these 8 lanes are not bifurcated. These 8 lanes are acting as one PCIe slot, and then these 8 lanes here are being bifurcated, but obviously that's pointless for this card. And it doesn't appear that there's any place in the BIOS to change the way that bifurcation is allocated. In other words, it would be cool if I could bifurcate this half of the slot into 2 4-lanes and this half of the slot into an 8-lane. That would be fine. Theoretically, that would work. But yeah, with this Gigabyte motherboard in particular, well, it's hard to see down there, but it's an A5201AC is the model number. Now, of course, there's a million different motherboards out there. The chances of you using this exact one are slim. So, but you know, if you are using this exact motherboard, I can say this card will not work with it if you want to use both SSD slots, which is a shame. And I really can't speak to it. That might be the case with a lot of Gigabyte motherboards that have a similar BIOS, although if they this only has the one 16-lane slot. If this was a bigger motherboard with more slots, it might have more configuration options for how to bifurcate each slot. So, yeah, this is a no-go. And now that I think about it, that may have been the issue with the T640 as well. I was also putting the card into a 16-lane slot on that machine because, again, as you remember, it wouldn't fit in an 8-lane slot because this notch isn't big enough on the card, the physical notch. So it is possible that the Dell system was doing something similar to this system. It might have just been allocating half the channels in that 16-lane slot into two 8-lane virtual or effective slots. I don't know what the correct terminology is. And therefore, this card may not have been working correctly. Although we were briefly able to see both drives, one of them didn't perform correctly, so I'm thinking that may have been the issue. So it may be that if I could put this card in an 8-lane slot that supports bifurcation into 2 4-lanes, then we might be golden. The problem is that I would need to use it in a system with an 8-lane slot that will physically fit the card. All right, let me get this system out of here. We'll try one more, just for fun. This is, I guess, the big brother to that other one. Completely different case. This is, in case you were curious, a Thermaltake Core V21. Okay, I got the gain really pumped up on this camera. As you can see, this has a 16-lane slot here that this 3070 is plugged into. It's got a 1-lane slot down there, which is going to be useless to us, and then I think another 16-lane over here with this other Elgato capture card plugged into it. So let me remove the Elgato card and replace it with the IC Dock ToughArmor or whatever. And yeah, this bracket also doesn't quite line up with the screw hole, but a little better than the other case. Maybe the other case was off a tiny bit geometrically. And this machine I use all the time. This is the computer that I usually feature on a direct feed in my videos, like if I'm looking something up or what have you. Okay, and as you can see, this is an ASRock motherboard. So different brand, maybe it'll have some different options for the PCIe bus and bifurcation. I'm not familiar with this BIOS, I don't go into it too often, so let me putz around in here real quick. Oh, well, there we go. PCIe graphics lanes configuration. Oh, it says on the right here, configure J10 slot PCIe lanes. Hopefully the J10 connector is the one that I have that card in. It should say on the board, I would think. No, it's labeled... Okay, I can see the label on the middle slot, and that's labeled PCIe 2. And I wonder if... Is there a slot under the graphics card? No, and just for the record, there's no slot under the double width graphics card. So on the motherboard, they're labeled PCIe 1, 2, and 3, and yet here it's saying J10. Oh, and this one actually is Gen 4 PCIe. So this one's better than the other two we tested it in, because it'll get theoretically full bandwidth for the SSDs. All right, this does at least give more options depending on what slot this is. It could be split into 2 8-lanes, an 8-lane, 2 4-lanes. I'm not sure what order that would be in, or 4 4-lanes, which is what I'll go for because we know that the card will then be in 2 4-lane slots. Let's just hope this doesn't kill the graphics. And by the way, we do have two... Oh, one of them just did some activity. That's probably a good sign. I just want to show you we had power LEDs. But I am not getting any video, which would certainly be the case if I change the graphics card. Oh, wait. I spoke too soon. It took a hot minute there, but there we go. I shouldn't have plugged this mouse into it. I hate SteelSeries I hate that about SteelSeries. Anyway. Alright, well, shit. It's only showing one of the two drives. Unless the graphics card is right now running on only 4 lanes. PCI current link with 4. Yeah, I guess that probably means 4. Like 4 lanes, but I'm not sure. Okay, so yeah, it did change it on that slot, most probably, assuming this is correct, which I would think it is, because it makes sense. All right, well, theoretically, there should be a simple fix for this. Swap the GPU and the IC dock card and see if that works. All right, well, this isn't going to be a real workable solution. Sorry, my hand's overexposed, but it's because this way you can see the inside of the computer. This card is pretty much a double width card, and there is a, well, let me get out of the way first. There is this connector for the front USB ports, which I don't need right now, but it sticks up quite a bit and it would obstruct the card from fitting in there. There's also this header here for the front buttons, and I think the card will clear that. And of course, it's not ideal for airflow because the fans are going to be right up against the side of the case. Fortunately, this case has venting on the sides, but I mean, this case is designed for two GPUs. Let me just bring us back to the other camera for a second, and you'll see the side of the case. It has this mesh on it for dust filtration, more or less, and I guess to prevent crap from getting inside otherwise. But anyway, this mesh here will be on against the GPU, and not super close to it either. There's some clearance. So theoretically, that's fine. It's just, this is starting to show the weakness of the IC dock card, in my opinion, where if your system doesn't support PCIe bifurcation on the slot you want to put this card into, then is it going to be practical for you to rearrange the other cards in your system to accommodate it? That is the question. Well, obviously, as you can see, the video card is functioning in that slot. I'm actually just, well, first let's see if we got both SSDs up. Hey, there we go. So yeah, that slot is the one that was bifurcated, and now we have both volumes. And by the way, off camera, I did format the Western Digital drive, which I believe is this one, and so that's why it's showing up in File Explorer. And I just want to really quickly go back into the display adapter and verify that it is now running on 16 PCIe lanes. And that still says 4. So is it bifurcating both slots then? Because that wouldn't be good. All right, I'm going to go back into the BIOS and see if there isn't another setting I was missing. It just says J10 slot, though. I wouldn't think that would change both slots. I mean, obviously, we don't want RAID mode. Yeah, so those are the only options. What model of motherboard is this? And can I check just to see? Oh, get details via QR code. Let's try scanning that QR code. Why not? I'll be the first one to admit doing this on my phone this way is kind of goofy, but this computer here is, of course, the one that I would use to show this content normally. And besides that, I scanned a QR code to get here. I mean, it just brought me straight to the manual, which is great. What is this AI? Is this AI bullshit? That is AI bullshit. Jeez, I don't need AI bullshit in a PDF reader. I gotta just completely get Adobe out of my life, but that's another story. I mean, the fact is, everyone's putting AI, that's in quotes, in everything nowadays. So it's kind of unavoidable. Oh, great. The menu it was in, AMD PBS. Down here it says, AMD PBS menu accesses AMD specific features. And then that's all it says about it. It does... Ugh. And bifurcation is not listed in the manual as a word. Freaking brilliant. Oh, duh. Let me see if the manual even references J10, because I just went back into the BIOS and was looking for any additional settings I might have missed. No matches for J10, even though J10 is... Okay. So this motherboard, okay. Irrespective of bifurcation, I guess if there's one 16-lane card in either slot, that's fine. If there's one card in each slot, which I'm assuming is what it means by dual, at 16-lane PCIe 1, 4-lane on PCIe 3. Yeah, and it says that for both. Okay. And where does this asterisk go? Probably nowhere, as most do not go anywhere. Oh, wait. For detailed product information, please visit our website. I'm on your freaking website. That's where the manual's hosted, you idiots. All right, well, I guess that answers the question. This system can't even support two 16-lane cards or even a 16 and 8, so it's not going to be able to support this. I mean, obviously this configuration is working, but the GPU, or the graphics card, is now only connected via 4 lanes, which is going to limit its performance tremendously. Meanwhile, I can access my 2 SSDs. So, that sucks. This computer is not going to be useful for testing. I mean, it's useful for... I guess I could use it for testing the cards anyway, or testing the SSDs. Yeah, let's do that. Let's do that. You know what? There's one more question I want to answer real quick, and that is, what motherboards are compatible with this, or does ICDoc even tell me? Because clearly there's going to be a lot of compatibility issues, even on systems that support PCIe Bifurcation. Wow, they got a lot of these. Wait, how big is this? What does this fit in 2 5 1/4 drive bays? I guess that's kind of cool. At least that's what it looked like proportionally. I don't really know. Okay. All the way at the bottom. To utilize an M2U2 and motherboard and AND card must support PCIe Bifurcation. Yes, we know that. Yep. For compatible hardware, please refer to the FAQ section. Okay. View compatible and incompatible motherboards. First of all, it's an Excel file. That's not... Okay. I mean, that's fine, I guess. I just don't know if I can read that on this system. Note, the compatibility list features motherboards with validated PCIe 16 slots. For 8-lane slots or motherboards not on the list, confirm bifurcation support with the motherboard manufacturer. But that is kind of bullshit, because if these motherboards weren't on the list, they're still not compatible with this card, at least not in a useful way in the case of this system. PCIe slots on motherboards may share lanes with others. For specific lane distributions, refer to the motherboard's official website or its manual. Fair enough, except my motherboard manual doesn't even mention bifurcation. And I don't have anything that can open Excel files on this system. Alright, well that was a quick installer at least. ASRock. Oh, okay. Yeah, I see. So there's tabbed at the bottom. ASRock. Wait. Sheet 3 of 3. There's only 3 motherboard manufacturers? Is this... It doesn't say compatible motherboards list A, so it's not like they have a different Excel file for every letter of the alphabet. Why are there only... So my Gigabyte motherboard wouldn't be on here no matter what. Search key not found. Oh. There's really not many of them. That's it. And what are the headers here? Oh. BIOS version, that's good. So let's just look for the word Phantom. Phantom Gaming 6. Okay, that supports it on all. And that is it, right? Yeah, that is it. This compatibility list is not very good, having 3 motherboard manufacturers, and they gave up halfway through the A's, and then they only list a handful of motherboards here. I mean, look, I can't expect ICDoc to correlate information for every single motherboard that exists, because there's probably thousands and thousands of them by now, like that have PCIe slots that this would go into. So, yeah, I can't blame them for that, but it is weird that it only goes through the A's. In case anyone was curious, because I showed the last system, we'll just do it in Task Manager, because that's easier. There's a Ryzen 7 3800X. Yeah, 64 gigs. What do I have in here? 970 EVO Plus 1 terabyte and 980 Pro 1 terabyte, which doesn't have a drive letter? Oh, it doesn't have a drive letter. This boots into Linux, right. I completely forgot how I had this system set up. This is a Linux boot disk. This is Windows. And these are the 2 drives on that card. So real quick, let's use, I don't know, Crystal Mark. So just to confirm, D is the Samsung. Let's just do all with the base settings just to see what that looks like. Ooh! Wow, that's hitting like the marketing materials there. Oh, and while that's running, you know what? Let's check out the back. Yep, got a nice blinking light there. I mean, I do like to see drive activity. It just helps me know I'm alive. Or that the system is alive, I guess. I should have done one iteration of each test, but whatever. Ooh, wow, that is, it's sequential, right? I mean, yeah, usually I'm copying large video files from place to place. And so I do a lot of large sequential reads and writes. So for me, that's a good performance metric, although I suppose I care more about performance when I'm sort of maybe randomly reading from it as I'm trying to edit a video, if I was using this my editing machine. Alright, well, this is an impressive result, I guess, because it's showing read speeds that are comparable to the marketing materials. 7450 megabytes per second, 7438 megabytes per second. That is really good. As is this write speed is actually kind of blowing me away. I never profiled one of these drives before, so yeah, 7 gigabytes per second sequential write, and this is crazy that, I mean, this almost seems backwards, but hey, good for it. Now, this video is not intended to solve the question of which is better, the Western Digital drive or the Samsung drive. These are ill test conditions, and I'm not doing this scientifically, but, you know, my own curiosity is taken over here, and I'm sure you guys are curious too, just to see what the comparison is. So, yeah, we'll just grab this screenshot. I could do this in editing, but it's kind of, for my own edification, better to see these side by side. Just for the fun of it, I'll switch I almost said Taskmaster. I've been watching a lot of that show lately. Switch Task Manager over to here just so we can see what the disk is doing there. Yeah, that's fine. Okay. Go with drive E. And let's see if this will live up to its marketing materials. At least what's printed on the box. Not its full specs, but whatever. Ooh. Loser. Actually, I'm being unfair. I just looked at the box again, and calling it a loser wasn't right, because this only promises reads up to 7.3 gigabytes per second. Whereas, again, Samsung promised us 7450. So, okay, it's actually really close. It's close enough as makes no difference. So, while the Western Digital is the loser in that test, it's doing what it says it'll do on the box, so I can't blame them. You know what I mean? Like, the only time I get mad about it is if a manufacturer promised something and then came in, like, well under that mark. But WD here is fine, because they're pretty much hitting the number they promised, as did Samsung. I'll give them both credit for those numbers. Even though, I guess by percentage, the Samsung is farther off its target. But again, not a scientific test. This isn't the most optimal system to test this in, nor the optimal circumstance, so whatever. While the test is running, I'd also like to note I've been touching the covers or the trays of the SSDs, and during the write tests, which are going to be the most intensive ones from a heat generation perspective, the Western Digital is getting much hotter to the touch than the Samsung, or was. Like right now, the Western Digital is running. I mean, it's so hot, I can't touch it for more than a second or two. Whereas the Samsung, when it was running its write test, it was quite warm, but not burning hot. Like the Western Digital right now is burning hot. Like that would actually, I think, I don't know that it would cause like a burn, but you definitely would be unwise to keep your finger on it. And there we go. And as you can see though, I mean, on the single-threaded reads, the Western Digital did much better than the Samsung. On the random 4K reads, it did much better. But yeah, so very, very close on the random 4K writes, which makes me think that might have been my system hitting its limit. Although I didn't see any like CPU utilization maxing out, but might have been one of the cores. I don't know. So the point is, don't use this as a guide to choose between these two disks. I will say they are pretty comparable. I don't know why we're seeing such a big difference in read speeds on sequential 1 megabyte single threaded. But yeah, both these drives are really good. The only oddity, like I said, is that the Western Digital seemed to get a lot hotter when running the same test versus the Samsung. The only thing that's got me curious is thermal performance. I can't give you a number, but I can guarantee the Western Digital is running hotter than the Samsung. I'm kind of curious to see if I do a write-only test, because I really want to kind of punish the disk here. And we'll just do 8 queues. I was saying threads before, I meant 8 queues. All right, we'll just up it to an 8 gig file. And so this should just do a sequential write test 9 times. And I just kind of want to see if it thermally throttles towards the end. You know what? I am going to just grab a reminder. So that's sort of what we had at the beginning of the test. I don't know why I grabbed that much of the screen, but whatever. Oh, that was too quick. I really want to, like I said, punish it. I can't do more than 9. All right, well, we'll just keep running it again. And again, and again. All right, I'm really curious to see at what temperature that drive is running. There's no way I'm going to be able to get one of these non-contact thermometers in there. And this one is in Fahrenheit. All right, this is saying 26 degrees. This is saying 23. Of course, I don't know which one's more accurate, but let's assume it's off by up to 3 degrees. We just want to get a decent idea. Let's switch back. Keep running the tests. Keep running the tests. I should have done something else with this software, but you know what? That's okay. All right, I got a little piece of foil tape. I'm just going to put the thermal probe on that and then stick this to the side of the drive. I'll show it to you later when I take it out. And I stuck it sort of where those flash chips should be on the front of the drive. I'm surprised that's it, actually. I thought it would be hotter. Oh, what the hell? It just glitched down to like megabytes per second. Like, what was that, 48 megabytes per second or something? That could be Task Manager, though. That might not be reporting it properly. I don't know. Average response time, was it that bad before? And we're creeping up to past 60 degrees-ish. Again, assuming this meter is accurate with this probe. I mean, so far the overall average write speed is down a little bit, but not like what I would call urgent thermal throttlingly down. Ooh, went down a little more. Interesting. Almost 62 degrees. All right, I'm going to do one more of these tests, and then I'm going to do a full suite of write tests just to see if there's any difference there. All right, came back up to almost 6,600 megabytes per second. And we're now at 63 degrees. I mean, if the temperature keeps rising, eventually it will thermally throttle in order to cut off that temperature rise. At least one would hope so. All right, so it got through all those. I'm going to do all. Okay, so even after a few minutes of writing sort of the maximum throughput to the drive, it doesn't appear really thermally throttled, although it did hit a fairly high temperature. I'm not sure where it would have thermally throttled. Yeah, the temperature was still trending upwards. I don't think this card is great at dissipating heat. Tape got a little dislodged as I was removing it, but the tape was there. That's where I had the thermal probe, and yeah, that's still plenty hot. And I think it was I think it was heating the Samsung. The Samsung's pretty warm still. Well, I guess here is where I'm going to conclude this video. Again, that wasn't a test of the drives themselves, like Western Digital versus Samsung. It doesn't matter which one you use. That was more a test of the thermal dissipation. And yeah, it does get hot. Though, for this application, if I had to pick one of these two drives, I would pick the Samsung. Based on my, non-scientific research here, it does appear the Samsung dissipates less heat, so it's a little more efficient on writes. And more importantly, even if all other things are equal, the Samsung only has flash chips on one side of the card, and that's the side that interfaces with the front, if you want to call it the front. I don't know which is the front, which is the back. That interfaces with this side of the tray, whereas the Western Digital has chips on both sides, and so it's trying to dissipate heat through this back plate, which is a piece of steel that's not coupled to this aluminum very well. At least with the Samsung, you're directly coupling the flash chips, or as directly as possible, to this big piece of aluminum, which is fairly substantial. Like this aluminum here is pretty thick. It goes around 3 sides. It's at the very least a good heat spreader. And also because it's aluminum, a lot more thermal conductivity than this, which I presume is steel, and is much thinner, not as much thermal mass. I think it's a bit lighter than the aluminum piece overall, although it's really hard to tell. It's still going to act as a heat spreader. But again, because of the way it's positioned in here, the back of this tray is not going to be able to dissipate much heat at all. There's not much interface with the air there. So even if you did have good airflow over this card, the back of the tray would be fairly insulated. Hence, Samsung's probably a better choice, unless it's like an 8 terabyte Samsung with chips on both sides. But ideally, I would get a card with just chips on one side of the PCB. Therefore, it interface with this aluminum chunk, which has not great airflow over it in this area, but better than the back of the card. So I think if I were going to use this for performance applications, I would go with the Samsung drive out of the two of these. All that being said, not extremely happy with this card. It's not the card's fault. The card seems to do what it advertises it will do. The problem is more finding the PCIe slot and or BIOS configurability to use the card. Like, I can't recommend you go out and buy this to solve your problem of wanting to put two M2 NVMe's in your system in a PCIe slot, because it might not work in your system. There's a good chance it won't. I mean, it didn't work. It kind of worked in the T640. I don't know what the deal was there. It didn't plug into an 8-lane slot there, which is probably why it didn't work out well. The other sort of normal, gaming style motherboard, I don't know what the other one was. This one is sold that way anyway. But the sort of the normal desktop motherboard that I tried it in over there, it didn't even support the right PCIe bifurcation layout for this card, even though it did support PCIe bifurcation. This computer supports the right type of PCIe bifurcation, but you can't use two 16-lane slots at the same time with all 16 lanes. That's probably a limitation of the chipset. So that's the motherboard's fault. But again, if I had just looked at the manuals for the two motherboards that I tested this with, they probably would have said, well, this one didn't even mention bifurcation. So I would have assumed it was incompatible. But even if I found out in the feature list it did support bifurcation, just knowing that your system supports bifurcation is not enough. It has to support bifurcation in the right configuration, the right permutation of lanes and slots. The problem is you're going to have to buy one of these cards and try it out for yourself, and then I guess return it if it doesn't work out. I mean, I can't give you anything more definitive than that. I really wish I could. I really wish I could say either this card won't work for you or it will, but it seems to be based entirely on the motherboard you're using. Though I will give ICDoc a mark down for... Why am I gesturing? I don't know. I will give ICDoc a mark down for not being able to fit this into an 8-lane slot, at least on that Dell motherboard. Probably others, let's be honest, those connectors are pretty universal. There's only a few companies making good quality PCIe connectors probably. So I wouldn't be surprised if this doesn't even fit in a lot of 8-lane slots. If they just made that notch wider, it would be fine. You could probably Dremel it out or cut it with some other tool. I don't want to guarantee that it'll work for you though. Not that I can guarantee anything in a YouTube video, but I don't even want to give you a clue in that could work for you, because I don't know. This is a really disappointing video for me, for you, for this product, because it's not a bad product. There are some little things they probably could have tweaked with it to make it better. I really like the fact that it has LED headers on here. I really like that for a custom build. I like that it has LEDs on the back as well. It's probably both, not either or. I'll also give them credit. This looks like a very high quality PCB. It looks very well made. Even though this cage is plastic, I think it would be better if it was metal for heat dissipation, if nothing else, as long as this coupled to that pretty well. But, to keep costs down, I can't blame them for using plastic. It's decent quality except for the cheap bracket, which bends super easily and doesn't have a great geometry anyway, just based on the way it's fitting into those two cases. So again, not a bad product, just a product that might and probably won't fit your system or work in your system the way you want it to. Now, to be fair, that's not ICDoc's fault. Presumably, if you were to buy any brand or any type of card that had 2 or 4 M2 connectors that go to NVMe drives that just use PCIe bifurcation, you'll have a similar issue. So that might be more limitation of where we're at with PCIe bifurcation in general. I can't even speak to that because I've only tried this in 3 systems, my scope of knowledge here is not super wide. I guess you could say I have 4 lanes of knowledge instead of 16. Now, that's a really bad pun or joke or whatever that was supposed to be. It wasn't even a joke. God, I don't even know. So like I said, my advice is if you like the concept of this card, buy it. If you have a different card that supports 2 drives using bifurcation right now, this will probably work. If you're not sure, I'm not sure. The only way you're going to find out for sure is to buy one, try it in your system. If it doesn't fit in an 8-lane slot, if you can't configure a 16-lane slot appropriately, return it. Make sure you get a return policy when you buy it. And honestly, I hate to do this, but like at this point, I've been spending like hours. I mean, this video is long, but it was edited considerably. I've been spending quite a lot of time effing around with this, effing around with BIOS settings, trying to get this to work in all 3 of those systems. I'm kind of done with it. It's frustrating, and that's the issue. It might well frustrate you. So it's up to you whether you want to go down that road. Anyway, thank you for watching. I've been Scott. I'll salute with the card, because that's what I'm going to do, is salute from now on. And I'll see you next time. Why am I so bad at YouTube outros? I will not see you next time. That would be freaking creepy. That's not how YouTube works, because I can't see you. You see me. That's the entire goddamn point of a YouTube video. And I've missed that point. But then again, it sounds kind of narcissistic to say, see me in the next video. Because then it's like all about me rather than about you, the viewer, who it should be about. So, I'll see you next time. Bye. Whatever.
Okay, the OS is booted up now, and this is as quiet as it'll get, with the least power consumption, I think. Much less than the old system. The only thing is, I forgot to reconfigure the NIC. It was using the optical NIC that was in the PCIe slot before, and that's how I have the OS configured. I want to use the onboard NIC, so let me go do that through the DRAC. And yeah, still pulling 106 watts. So we'll see how much it goes up once the drives are in, which is the next step.
Ooh, 300 watts, 318 watts during startup. But no, that's only brief as it's spooling up. Drops back down to, oh, it's going back up. I think the drives are spooling up in order. The fans just died down. Not full fan throttle, but still medium throttle, I would say. Just went down. Okay, everything's kind of quieted down, and we're at 280 watts. I'm guessing that's about where we'll sit. Okay, I'm gonna go check on the operating system. I'm gonna SSH into it and make sure it's booted up, and the disk array is good.
После небольшого инцидента видео продолжается.
Okay, confirmed. The system is booted and the array is clean. All drives are present. So now what I'm going to do is start a consistency check on the array, which will use the drives pretty hard, and we can see how power consumption goes up from there. And let me check the sound levels and power first, because this is what it'll be using, sort of running normally at more or less idle. And it is using 234 watts, 38, thereabouts. Let's call it 230 to 240. I figured I'd perch here awkwardly while this thing does its consistency check, because I want to let it do it for a few minutes before measuring the sound levels and power. More so the sound levels, give that chassis a chance to heat up and the fans to therefore spool up. So there it is. You'll see I'm sweaty. That's because it's 95 degrees here in New York right now. If it was 95 Celsius, I'd just be dead. So obviously I'm at Fahrenheit. Yeah, hence the sweaty shirt. Did it all for the video though. Turned off the AC so that it wouldn't interfere with the readings. The only thing that did interfere with the sound level readings is the computer up there, and that doesn't produce much noise. I didn't want to shut it down because it's a backup server. It's actually doing backups right now. Eventually this will replace it. I just haven't migrated all the scripts and all the actions. Like, it's a software issue. I just haven't migrated everything that server does down to this one yet, even though this one has more than enough storage space for both. I think that one up there has 10 4-terabyte drives in RAID 6, so that's a mere 32 terabytes. It's like 1/10 the storage of this guy. Anyway, so you can see it's blinking away. That's great. I got one more special treat for this server. I ordered a front panel for it. I almost never use front panels with my servers, and by almost I mean never. Like, I always take them off if they come with them from eBay, but this one did not. This server though is in a spare bedroom basically. We kind of use it as a closet. Well, whatever. It doesn't matter why we use it as a closet. The point is, I'm not going to be the only one with access to this room, so I figure locking front panel, not to prevent anyone from like doing anything nefarious, just to prevent anyone from accidentally bumping into the front of it and dislodging one of the discs or something, or turning off the power, which I definitely don't want. So, and there we go. I'm probably not going to lock it because I know what's going to happen. It's a common type of key, but I'm going to lose the key. I might attach it to the back of the chassis, but I'm not going to lock it for now. I'll leave the key right there. Like I said, it's to prevent someone from accidentally messing with this, not from purposefully going to trouble of taking the cover panel off and then messing with it. So I think it's fine. I mean, this is the cover panel that's made for this computer, obviously, but it clearly does obstruct airflow slightly. So I'm going to leave it on there just to get the final sound measurement, just to see if the fans spool up any more than they already are. It's still pretty quiet. And I should note that while this machine is definitely not quiet, like, you wouldn't want it, if you're the type of person that likes absolute silence while they work, don't put one of these next to you for a good reason. But I think if it's in a spare bedroom or a closet in your house, especially if a door is closed between you and this, it won't bother you. I wouldn't think. The big upgrade for me is not that this is overall quieter than the one that preceded it, but that disk array, the computer itself that was here, was very quiet. I think it has huge fans, like high quality, not Noctua, but some high quality fans, running relatively slow. that computer was almost silent, quieter than this for sure. The disk array that I had propped on top of it, that thing's loud. Especially when under load. Like when that computer was doing an array rebuild of that array that was on that disk shelf, man, like it was almost screamingly loud sometimes, especially if it got hot in this room in general. Like when the AC's not on, like it's spring, fall, but it's still kind of warm out. Yeah, it would just get super loud. Worst part is, and I think it's because I put it in the middle of this closet is above my main staircase to the first floor. We're on the second floor right now. I guess you didn't know that. And it caused this box to resonate like horribly. So like if you're walking up the stairs and this was doing a array consistency check or just backing up a lot of data and the drives were working hard, you would hear the drives like rumbling through this. It's like the walls are kind of hollowish. It's just a closet. It's not, very robustly built, I guess. I mean, the floor is fine, but the cacophony as you're going up the stairs, you couldn't really hear it from the rest of the house. Also, another issue with the noise is the quality of the noise. This is producing a nice low hum. Well, sort of like a whooshing noise, but hopefully that comes through on camera. That whooshing noise is not unpleasant. The disk array that was on here had kind of, I don't want to say screamy fans, because like, a 1U chassis running fans at full throttle, like that's a server that screams at you. But it was higher pitched than this and kind of more of a grating noise, more of an irritating noise. So this, even if it was the same loudness as that disk array, this would be a huge upgrade right off the bat, but it's also definitely quieter. So yeah, this was clearly the way to go. I'm glad I didn't go with a rack chassis. That would have made more noise and wouldn't have held 18 disks, at least not one of the common Dell chassis, or HP for that matter. So yeah, final sound measurements, and I'm going to change my shirt and turn the AC back on. Just about 55 decibels. And power-wise, ooh, exactly 300 watts. Okay, more or less. Yeah, let's call it 300 watts. And that is obviously during a consistency check when the disks are being worked relatively hard. So this is like a worst case scenario for this computer. Oh, and I should note, I have both power supplies from this computer plugged into the top UPS right now. Ultimately, right now I guess, I'm going to switch it so that one PSU is going to each UPS. That was just so we can get a power measurement from both power supplies off the top one. Could have just plugged in one power supply, but I guess it's actually kind of good to see the overhead of these other power supply included in that figure. UPS might not be the most accurate power measurement tool, but it should be pretty good. Good enough for my purposes. I just want to get a good range of where the server is going to operate, because it's never going to be a consistent amount of power anyway. It's going to fluctuate up and down as it's busier or more idle. And kind of just to see the differential between no disks and disks actually working. So that's really the only purpose there. I was going to take out two watt, volt, amp meters, the little plug-in kinds, and plug one into each PSU and test it out that way. I was like, why am I going to bother? The UPS will tell us. That'll be fine. So yeah, I guess that's it. I'm going to swap those power connectors and then change my shirt and turn the AC back on. Yeah. Just for posterity, I should point out the bottom UPS is for the computer on top, ironically. I actually had them the other way around before. I should have done that again, but whatever. It doesn't matter. They're labeled. The point is 86 watts for that machine up there, which has, I think, I'll confirm it in the edit, it has 10 4 terabyte drives. It's a very light power consumer on its own. That's going to be mostly the drives and some PSU overhead. I'm pretty sure I put a gold 80 plus PSU in there. Anyway, point is, you kind of get an idea that obviously this chassis and these drives are much more power hungry than that chassis and those drives. And actually, just to show you, the power supplies are running in grid redundant mode. Now one PSU from this is plugged into the top UPS, and one in the bottom UPS along with the computer on top. And you can see it's dividing the power amongst both, which is great because this way, if one UPS fails, the other one will pick up the slack. If it's a power failure, then I'll have double the runtime, essentially. A little less, obviously, because of that one having more power draw via that computer. And I guess it's really neither here nor there, but this access point is for my guest and IoT networks, and I have 3 of these, one on each floor, so that's why I was able to just disconnect it. It doesn't matter. Whatever devices will pick up the other access points. But still, should plug it back in. Yeah, just put it on top of the computer, right? Can't do any harm. Eh, fini. Fini? Who speaks French? Well, except for all French and Canadians, but you know what I mean. I don't usually speak French.